Hello everyone, my name is Ethan. Welcome back to the channel where today we are going to be continuing in C# with classes. So in the previous lesson we learned about arrays and loops. Today we are going to learn about classes and objects. It's going to end in a quiz and perhaps a project here. So we will have a good time there. Without further ado, let's just jump right into it. Introduction to classes. With data types like int, string, and bool, we can represent basic data and perform operations. For example, we have a variable named count that holds the value of 32. It's an int variable. And when you use the count++, it's going to increase the value of count by 1. What if we want to represent something more complex, something in the real world? Say we are writing a program to manage nature reserves and we need to track forests. A forest has a certain number of trees, it has a name, it can grow, it can burn. Representing many forests with basic data types would mean tracking tons of separate variables and separate methods. Instead, we can define our own custom forest data type and use it like any other data type in our program. This process of bundling related data and methods into type is called encapsulation, and it makes code easier to organize and reuse. In C#, a custom data type is defined with a class, and each instance of this type is an object. This lesson will teach you how to first define a class, add members like properties and methods to a class, customize access to those members using public and private, and creating objects from a class. In your coding adventures, you may come across the term struct. While similar to a class, it has a few differences, but we won't be covering those in this lesson. If you do find yourself in need of a struct, you can refer to Microsoft explanation. Structs are easy to learn after you understood classes in this lesson. Let's get started. So obviously we are starting off a new section. So let's start off with a fun little graphic here. My webcam is going to be blocking a little bit of it, but that's going to be all right. So we have a light bulb class and it has a couple of different values. Is on, that's obviously going to be a Boolean. Is the light on or not? Watts, the number, perhaps the actual wattage of the light bulb. And then a method, turn on. We want to be able to turn on the light bulb. And there's a couple other here that make sense. So like microphone, what color is it? Is it analog? Record, animal, color, age, speak. And then the date one, I'm cutting off just a little bit here, but in it, it has month, year, and toString. So let's just hop in. Let's learn how to create a class. C# provides built-in data types like string. An instance of a string type has its own values and functionality. So in this case, we have a string variable named phrase that holds the value or string zoinks. We can do a console.writeLine and get the length of it, as well as a console.writeLine and get the index of the letter K. In this case, it would be number 4 there. In this case, phrase is an instance of the string type. Every string has a length property and index of method, but the resulting values are different for each instance. A class represents a custom data type. In C#, the class defines the kind of information and methods included in a custom type. You can make them instances of that class. Above, phrase was an instance of string. There may be instances of the same class, all with unique values. To begin defining a class, C# uses this structure. So we'll use that keyword class, and then we'll add the name of the class, and then open it up using the squiggly brackets, or what do we call these? Squiggly brackets is fine. The code for a class is usually put into a file of its own named with the name of the class. In this case, it's forest.cs. This keeps our code organized and easy to debug. In other parts of code, like main in program.cs, we can use the class. We make instances or objects of the forest class with the new keyword. Forest_f equals new forest with the parentheses there and a semicolon. We could say f is an instance of the forest class, or f is of type forest. The process of creating an instance is called you know what? Just so we get it 100% correct here, let's hear it said out loud.
Instantiate.
instantiation. Called instantiation. Today we instantiate a class. Yesterday they instantiated a class, and so on. We will define our class in forest.cs and work with that class in the main.method program.cs. Within the namespace basic classes, build an empty forest class in forest.cs. So if we go into here, we have namespace basic classes. So we will define a class by saying class forest, and then we'll bracket it open. We're going to first, of course, just build an empty one so we have the correct structure here. Now, in main, in program.cs, make an instance of the forest class and store the result in a variable named f. So now if we go back into this program.cs, we can do a new claim by doing forest f is equal to new forest with the parentheses here, remembering our semicolon. And I'm hoping that works, and it does. We did that correctly. Perfect. Fields. We need to associate different pieces of data, like a size and a name, to each forest object. In C#, these pieces of data are called fields. Fields are one type of class member, which is the general term for building blocks of a class. Create fields like this. So inside this forest class definition, we will do public string name, public int trees. This might look similar to defining a variable. It is. Each field is a variable and it will have a different value for each object. With the code above, we haven't set the value of either field, so each has a default value. In this case, string s default to null and ints to 0 and bools to false. You can find the default value for more types in Microsoft's default value table. It is common practice to name fields using all lowercase, name instead of name. This makes fields easy to recognize later on. Don't worry about public yet, it's explained later in this lesson. Once we create forest instance, we can have access and edit each field with dot notation. So we have a forest f.new, new, and then we can access what name it is by saying f.name, Amazon. Console.writeline f.name would print Amazon. Now if we do forest f2, a new instance of forest, we will find that if we name it Congo, it will print out Congo. Each instance has a name field, but many differ across instances. In forest.cs, add 4 fields to the forest class, 2 fields for string type, and 2 fields for type int. So if we go back here, we are able to access this by starting a couple of new fields, first one being name. And I believe if we just leave it alone, we actually do have to do public first. So we do want to remember that keyword of public, right? And then we'll do a couple more here. Public string biome, public int trees, and public age, int age. Now we should be able, that should hopefully be correct there. We do. Morning forest.trees is never assigned to and will always have its default case. So let's go back here. I think we did this correctly. Let's go back. In main, a forest object has already been instantiated. Set values to those 4 fields. So let's actually set the values. So if we do f.name, we'll set the name equal to dmx forest. If we do f.biome, we can set that equal to rainforest. If we do f.trees, we can say that there are 10,000 trees. And if we do f.age, we'll say that it is 120 years of age. If we run this now, hopefully this works. Perfect. In main, print the name of the field, print the name field to the console. So we'll do a nice little console.writeline. And inside that, we will put f.name to the console. And hopefully we have done everything correctly. And perfect. We do print out DMX Forest to the console. All right, properties. As of now, a program can plant any value in a forest field. For example, if we had an area field of type int, we could set it to 0, 40, or negative 1,249. Can we have a forest with negative 1,249 area? We need a way of defining what values are valid and disallow those that are not. C provides a tool for that, properties. Properties are another type of class member. Each property is like a spokesperson for a field. It controls the access, getting, and setting to that field, and we can use this to validate values before they are set to a field. A property is made up of two methods, a get method, or getter, called when the property is accessed, and a set method, or a setter, called when the property is assigned a value. This area shows a basic area property without validation. So inside of the public int area, we do public int area, open it up with brackets, and have a get and a set. So we'll return area, area is equal to value. The area property is associated with the area field. It's common to name a property with the title cased version of its field name. Example, age and age, name and name. The set method above uses the keyword value, which represents the value we assign to the property back in program.cs. When we access the area property, the get and set methods are called. So set is called and get is called, prints -1. In the above example, when set is called, the variable or the value variable is -1, so area is set to -1. Here, the same property with validation in the set method. If we try to set area to a negative value, it will be changed to 0. Public int area get return area set is else. Perfect. In program.cs, forest f equals new forest. Set is now called. When we do f.area is equal to -1, get is called and prints 0. Define a basic name property for the name field. The getter and setter will have no validation. So if we go into this forest, we'll go into the name by doing public string name and then open that up. I believe it doesn't want us to do anything quite yet. No, it actually wants us to put in the get and set. So we want to do something that looks a little similar to this. So we'll start off by doing a get, and inside the get, it doesn't want us to put anything in it quite yet, but we will initialize them by doing just get and set. And hopefully that works. So still not getting what we want, not all code paths return a value. So let's get a hint here. It looks like it wants us to just return area. I don't see how they wanted us to know that, but in this case, I guess it doesn't matter. In the set, we're going to do area is equal to value, and now we should be fine. Nope, it's saying that I'm doing something wrong here. If I look, though, where am I getting it wrong? Was I supposed to do it with area? Name property, public string name, get and set. I'm saying name. So return name, and then instead do name is equal to value is I think the issue that I'm having. Okay, cool. All right, perfect. That actually ended up doing it nicely there. Define a basic trees property for the trees field. The getter and setter will have no validation. So instead for this one, again, we'll do a public int trees, and we will open that up, have a get method that will return trees, and a set method that will have the value of trees equals value. We're just going to do the same thing, and I believe that should work. Taking a little bit to load there, but that's exactly what we want. So now let's head over to program.cs, replace any use of the field f.name with the property f.name with a capital. So we'll do that quickly. And it wants us to also replace the fields f.trees with the capital f.trees. Currently, I don't see anything else, so I should just be able to, oh, never mind, I lied. Now if we click run, we should be fine. Perfect. So let's go back into forest.cs. Let's define a biome property for the biome field. It will have a getter and setter. The setter should only allow 3 values: tropical, temperature, and boreal. If any other value is used, set biome to unknown. So we'll go into biome here and we'll create a public string biome with that capital B. Open it up, have a get method that will return the value and to do a little list there, we might want to use an array, but let's see what it wants us to do, in fact. Value, okay. So it wants us to do something. I am going to quick reload the page as it is getting a little laggy, and that's fine. So it wants us to do something like this. So in this, we will still just return biome. That's what we want as the return value. But when we set the value here, we're going to do something pretty interesting. We're going to open this up and do an if-else statement. So if, and we want value is equal to, we want the value equal to the name tropical or value equals temperate or value equals boreal. And in that case, what we will do is if value is that, then area is equal to 0. I see. So if that is the case, then biome is equal to value. And then we do an else statement here. Else value is equal to unknown. All right, hopefully I'm doing that right. Let's run it and see what happens. I assume I might make one little mistake here, possibly, but yep. Expected default to go to unknown, tropical, temperate, and boreal if any other value set biome. Oh, I see. I should have set biome equal to unknown, not biome equal to value, or value equal to unknown. That was an easy little mistake there that you can make, so be careful, and it looks like I got it correct. Let's view the solution and see how they ended up doing it a bit different. So they did if, and then, oh, very similar to what I did. They just kind of did it on top of each other, where I did it all kind of in this one line here. So good to know that I did it kind of how the solution wanted to do it, and that always makes you feel good. Automatic properties. It might have felt tedious to write the same getter and setter for the name and trees properties. C# has a solution for that. The basic getter and setter pattern is so common that there is a shorthand called an automatic property. As a reminder, here is the basic pattern for imaginary size properties. We just do that get, return size, set, size equals value. This pattern can be written as an automatic property if we just do get, set. In this form, you don't have to write out the get and set methods, and you don't have to define a size field at all. A hidden field is defined in the background for us. All we have to worry about is the size property. Replace the current name field and name property with the automatic name property. So it wants us to go into the name property, and instead of writing this out, it wants us to just have the one thing where we do get and set. And if we do that, hopefully it should work. It wants us to remove replace the current name field and name property with the automatic name. So it wants us to define an automatic property cook time like. I'm a little confused. It wants us to do something where we remove field name. String name, so it wants us to get rid of this. Perchance, get rid of that. Actually, yeah, we do get rid of that. So replace the current trees and trees property with the automatic one. So again, we're going to get rid of trees here. And instead of this, we will just do get set. Perfect. All right, let's learn about public versus private. At this point, we have built fields to associate data with a class and properties to control the getting and setting of each field. As it is now, any code outside of the forest class can sneak past our properties by directly accessing the field. So f.age equals 32 using property, f.age equals -1 using field. The second line avoids the property validation by directly accessing the field. We can fix this by accessing modifiers public and private. A public member can be accessed by any class, and a private member can only be accessed by code in the same class. For simplicity, we've been adding public to every member so far. That allows us to code with the access to members from the main method, which doesn't belong to the forest class. When we switch a field from public to private, it will no longer be accessible from main, although code inside the forest class like properties can still access it. Access modifiers can be applied to all members of a class, including fields, properties, and the rest of the members covered in this lesson. Remember, encapsulation, public and private, are necessary to encapsulate our classes. Think of it like defensive coding. You're protecting the inner mechanisms of a class with private so that other code can't break your class. You can only expose what you want to be public. For example, since a class properties define how other programs get and set its fields, it's good to practice to make fields private and properties public. C# encourages encapsulation by defaulting class members to private and classes to public. All right. Currently, the biome field and biome property are public in program.cs. The field is directly accessed to be desert, an invalid value. Run the code to see if desert is the field's value. So if we click run, we will notice that yes, desert is here. By directly accessing the public biome field, the code skipped the validation. Let's prevent that by setting biome field private in forest.cs. So we'll go over to forest.cs, and instead of biome being a public, we will change it so that it is private, and I would assume that we would also change this to private. When you run the code, you should see the error, forest.biome is accessible due to its protection level. That means C# has prevented us from accessing a private field, which is good. Perfect, exactly what we see. Addressing the error by changing the code in program.cs using the biome property instead of the field biome, you need to change code in two places in the file. What is printed to the console now? So if we go here, instead of desert, address the error by changing the code in program.cs, use the property biome instead of the field biome. So instead of biome, we'll do biome. You'll need to change the code in two places in the file. What is printed now? If we print now, I may have been too hasty in changing the fact that this, I suppose, should have stayed public. Use f.biome instead of fbiome. Thought that's what I was doing there, but I guess let's print out f.biome. Unknown. So now when we try to do a desert, it's not going to work. It's going to go through our security system and our little setups that we did in the get and sets, and it will actually access that. So that's pretty nice. Get only properties. Previously, we used properties for field validation by applying public and private. We can also use properties to control access to fields. Recall our imaginary area property. Say we want programs to get the value of the property, but we don't want programs to set the value of the property. Then we either don't include a set method or make a set method private. This shows approach 1, doesn't include a set. And this, we can still get area, but if we try to set area, we get an error. This shows approach 2, make set private. So private set area. We can still get area, but if we try to set area in main, we'll get an error. Notice that in approach 1, we get an error for setting area anywhere. In approach 2, we only get an error for setting area outside of the forest class. Generally, we prefer approach 2 because it allows other forest methods to set area. In forest.cs, define an age property for the age field. It should have a public getter and a private setter. So we'll go into the age thing here. If we now print out below here, it wants us to have a public setter and a private getter. Or sorry, opposite there. So let's again do public int age. We'll open that up. In the get, it wants to be public. We will return value. Or no, we'll return age. And then we'll do a private set where in this one we'll do age is equal to value. And I'm hoping that's what they want us to do. It is loading. A little slow this time, but that's okay. We're just going to have a great time. Perfect. We did it correct. Let's go to number 2 here in program.cs in main. Try to set the value of f.age. You should see an error. So if we try to instead change here to f.age. F.age. What am I doing wrong here? f.age. You should see an error. This error means the private setter prevented us from setting age outside of the class, which is good. So we do see the error cannot be used in this context because the set accessor is inaccessible. Perfect. Okay, let's move on here to methods. The third type of member in classes is methods. This lesson assumes that you're already familiar with methods. If you're not, please check out my video on methods. It's a previous video inside of this playlist. In the past, you learned that methods are a useful way to organize chunks of code to perform a task, but most methods belong to a class, even the ones you've written. So methods are used to define how an instance of a class behaves. You can think of them as actions that an object can perform. This code defines an method increase area that changes the value of the area property. So we have a class, we have public int area, public int increase area, and in that method we have area is equal to area plus growth, return area. You would call the method like so. So we would first create that new variable using forest f equal to new forest. Int result is equal to f dot increase area 2. Console.writeLine result prints 2. Perfect. In the forest class, define a public method grow. So let's get in here, and in the forest class, we are going to create a new public method called grow. So public, we'll call it, actually we want to know what returns. Take 0 arguments, return the updated number of trees. So it's an int return, right? We'll return a grow, and inside it should take 0 arguments, which is fine. We'll open that method definition up a little bit. In the method, it says it should increase the trees property by 30 and the age property by 1. So we'll do trees plus 30, age plus, we could do age plus plus just to add by 1. and return the updated number of trees. So in this case, we will have return trees. And I'm hoping I did that correctly. It doesn't look like I did. Let's take a peek at the hint here. Here's the first line of the method definition. That doesn't really help me all that much. It wants to tell me here, only assignment call increase could be used as a statement. So in line 43, it's not liking this trees plus 30. Let's do trees plus equals 30 instead and not really mess up our method there. Now that's should be a lot better there. Obviously, if we did trees plus 30, that's not exactly how the syntax is. You want to have that plus equals, so we add to the value of. Let's define another public method called burn. And in burn, it should take 0 arguments, decrease the trees property by 20, and increase the age property by 1 to return the updated number of trees. So it's going to be another int return, and we'll define it as burn. Open that up a little bit, and it should take trees minus equals 20, and increase age property by 1. So we'll do another age plus plus, and then return trees. Perfect. All right, let's continue here with constructors. In each of the examples so far, we created a new forest object and set the property values one by one. It would be nice if we could write method that runs every time an object is created to set those values. C# has a special type of method called a constructor that does just that. It looks like a method, but there is no return type listed, and the method name is the name of its enclosing class. So if we look here, we have a constructor. It looks something similar to this. So we're trying to define a class here called forest. We open it up, and all we do is call forest. We can add a code to the constructor to set values to fields. So like so. We have set a little bit of area equal to area. This constructor method is used whenever we instantiate an object with a new keyword. So a constructor is called here. So we have a forest object called f, where we create a new forest object, and we have the value of 400 in here. But we've been instantiating new objects all day. Why did it work before when we defined a constructor? If no constructor is defined in a class, one is automatically created for us. It takes no parameters, so it's called a parameterless constructor. That's why I've been able to instantiate new objects without errors. Let's define a constructor for the forest class. It should have 2 parameters, name, which sets the name property, and biome, which sets the biome property. It should also set the value of age to 0. So let's go up, look at the syntax one more time here. Inside of it, we should have a, afterwards, we'll go all the way down here to the bottom, and we will do this new constructor variable, where we'll just do public, and then we'll do forest. And it should take 2. If we go back down, it says it should take 2 parameters. The first one being name, which should be a string name. And I believe biome is also a string value. Biome. We'll open up that constructor. And inside the constructor, we're just setting area. We're just setting these values equal to the previous one. So we're setting name equal to name, biome equal to biome, and we will also set age equal to 0. And let's hope this works. We are getting a little bit slower, so I am going to just relaunch the page quickly. I believe what ends up happening most of the time is it keeps the other pages that we've gone through loaded in the background just in case we want to go back to them. And so once we run it, it's really going to start running slow, which is fine. Obviously, if we have a lot of different tabs open, we ended up getting that one correct. I am going to just quickly relaunch the page here, refresh us, and get us back connected to Codecademy. Perfect. Okay, so we got that first part right. In part 2, though, the code in program.cs has been commented out, uncomment it, and run it. You should see the error. Okay, so let's get rid of these little comments here, and we'll run it. When we run it, we notice that, yes, we do in fact get a error CS7036. And that error says there is no argument given that corresponds to the required formal parameter name of forest.forest string. So this error occurs because you're using a parameterless constructor forest in program.cs. This no longer works because a constructor forest string has been defined. Call the new constructor in main to create a forest object with the name Congo and biome tropical. So instead here we will start off with Congo, and in this we'll add tropical. And I should have deleted these lines that say f.name and f.biome, but we did get this correct. Let's do that. And they're no longer useful because the properties are now set in the constructor. Perfect. This. In the last exercise, we used the area field in the constructor. Class forest, public int area, public forest int area, area equals area. The parameter for the constructor area looks a lot like the old field area and the new property area. It's good to be explicit when writing code so that there is no room for misinterpretation. We can refer to the current instance of a class with the this keyword. So class forest, we have created a, we're just omitting the property there, but in the constructor, we're saying this.area is equal to area. This.area equals area means that when this constructor is used to make a new instance, use the argument area to set the value of the new instance's area field. We would call it the same way. So forest f equals new forest 400. F.area now equals 400. The word this might seem frustratingly vague. Think back to the class is to instance as blueprint as to the house analogy. This class slash blueprint has to generate the generic this because the class slash blueprint is going to be used for every instance slash house. Specify the instance properties by using this.name and this.biome. Okay, simple enough, of course. We're going to scroll to where we have instantiated or put our constructor here, which is this, and we'll instead do this.name and this.biome. And we will run our code and see what happens. Perfect, we ended up doing it correctly. Overloading constructors. Just like other methods, constructors can be overloaded. For example, we may want to define an additional constructor that takes one argument. Public forest int area string country, this area, or just area, right? Whereas the country is unknown. The first constructor provides values for both fields, and the second gives a default value when the country is not provided. Now you can create a forest instance in two ways, by putting the area and the country, or just the area. Notice how we've written duplicate code for our second constructor. This area is equal to area. Later on, if we need to adjust the constructor, we'll need to find every copy of the code and make the exact same change. This means more work and more chance for errors. We have two options to resolve this. In either case, we will remove the duplicated code, use default arguments. This is useful if you're using C# 4.0 or later, which is fairly common. And the only difference between constructors is default values. So instead here, we would add string country is equal to unknown. That way, if it's not specified, we will automatically just put it in as unknown. use this, which refers to the constructor of the same class. This is useful for old C programs before 4.0, which at this point, we are very far past 4.0. So remember that this area refers to the current instance of the class. When we use this, like method, it refers to another constructor in the current class. In this example, the second constructor called this, which refers to the first forest constructor, and it prints out information to the console. So let's define a second constructor for the forest class. I'm going to do it right under the first constructor here. It should take one parameter name. And it should use this, and it used it like something like this. It should also print a warning to the console about the defaulted value. So inside of this, we'll write console.writeLine saying biome not specified, value defaulted to unknown. Okay, and then we're going to want to do that this area with the colon, this area, or sorry, name unknown. Let's see how that ends up working out for us. Expected, oops, you know what? I was doing so well in this video too. We're 41 minutes in. At some point, I'm gonna go a video without doing it. Well, let's look at the second one. We ended up skipping it a little bit. In main, call the second constructor to create a forest object named, I'm not even gonna try. So in this case, we're gonna create a new forest object called Rendlesham is equal to new forest with the values of Rendlesham, and that's it. I might just do, instead of F, I'll just do G in this case. Below the constructor call, print the biome property of this new instance. When you run the code, you should see a warning message and unknown printed to the console. Why are these two things printed? So now if we do a console.writeLine g.biome, we should see an error in the top right and unknown. So biome not specified, biome defaulted to unknown, and unknown printed. So why are these things printed to the console? Because we gave it a default argument when we did this, right? And that's where it's showing we know exactly what the name of the forest is, but we don't know what the biome of the forest is, right? So we're defaulting it to unknown. Okay, simple enough review. Congrats, you finished a lot of content and some of the most important concepts in C#. When someone asks you, how do I make custom data type in C#, you can talk all about it. In this lesson, you learned how to define a class, instantiate an object using new, define fields, define properties, define automatic properties, define methods, define constructors, overload constructors, and control access to class members using public and private. Try to complete our forest class in main. So we are going to print trees console, instantiate a new object named Amazon, store the result in a variable. So we'll do this by doing forest f is equal to new forest object with the name Amazon. We've created that. Let's print trees property to the console. So if we do a console.writeLine and we print f.trees to the console, call the grow method. So now if we do f.grow and print trees property again, I'm going to just do a nice quick little Control-C, Control-V, and let's print it out and see if everything worked as intended. So it started at 0 and it went to 30. Perfect. Let's take a peek at what is up next. I believe we'll maybe have our quiz. All right, perfect. We have an 11-question quiz here. When main is run, what will be printed to the console? So we have a class called program, and in program, it has a couple of interesting things. First and foremost, we have the main argument. Obviously, this is just what we're running when we do main, but let's look at the class player. So with player, we have a constructor here that tells us that it should take a string and name, and then it will write player named, colon, and then their name. And then we have a public player just in case they don't enter in anything. So when they don't enter in anything, it will be NA, right? It's going to just print NA because this is the default, right? So it will play player name NA, correct. The second constructor calls the first constructor with NA as an argument. Perfect. Create an instance of a chainsaw class which has parameterless constructor. So we want to have that new argument and then chainsaw, as that is the name of the argument. So we got that one correct. Given this Space Invader class, what is Space Invader? So we have the class Space Invader public, and we have a constructor that takes just speed. It has no arguments though. And then we have a couple of different things. First, we have a variable that is a Boolean variable, and they're just get set. So what is Space Invader? A Space Invader, is it a property, a field, a non-constructor method, or a constructor method? I'm going to say it's a constructor method, and that is correct. A constructor method is a method with the same name as its enclosing class. Perfect. Given the Space Invader class, what is speed? So is speed a field, a constructor, a property, or a method? So when I look, I see that it has a get and a set. That makes me think it's not a constructor or a field, and I don't think it's a method. So I would say it is a property, and that is correct. Given the breakfast class, what is ingredients? So we have a class called breakfast that will create a string array called ingredients. So what is it? Is it a field? Is it a constructor? Is it a property? Or is it a method? Well, for sure it's not a constructor, and for sure it's not a method. So is it a field or is it a property? Personally, I'm going to say a property, but it is a field. A property would have a type in its definition. That's good to know. It would have a type. So a little bit of a slip up there. That one should have been a little bit thought more through. Given the unicorn class, which line in main will cause an error? So classing unicorn int horn length get private set. So when we try to set the value of unicorn horn length, we're not going to be able to do that. So I'm going to say u.hornLength equals 5 is going to give us the error correct. The set method for horn length is private, so it cannot be accessed by other classes. An instance of the random class is constructed below. Call the instance method next, which returns a random integer. So we have random generator, new random, int guess is equal to, let's call the instance method next, which returns the thing. So we'll do new random, int guess should just be random class could do call the instance method, which returns a random integer. Let's finish it off with next, and we'll do something that looks very similar to this, I would say, because we have a variable called generator, and we're going to use that next function. That is correct. Which of these is not a class member? So method, object, property, or constructor. So it's not going to be an object, right? Because an object is an instance of a class. It's not a part of the class definition or a class member. What is a class? Is it a file in C#, an object, a definition of a custom type, or the main method? So I'm going to say that it's the definition of a custom type. Correct. In C#, a class defines the kind of information and methods included in a custom type. define encapsulation. Okay, this one might be a little bit challenging for me. I'm not the best at definitions. Encapsulation means all class members are private. Don't really think that's the correct answer. Encapsulation is a type. Encapsulation means building related data and methods into one logical group. And encapsulation is an instance of a class. I'm going to go with the longest answer in this one, just because this makes the most sense. I don't believe it's just a type. I don't believe it's just an instance of a class. Encapsulation means all class members are private. Could have been that, but I'm going to go with my gut here and say it was this one. Correct classes are one way to implement encapsulation. What is an object? So the definition of a custom type, a class, an instance of a class, or a member of a class. I'm going to say an object is an instance of a class. That's correct. If a class is a blueprint, then the object is a house built from that blueprint. Perfect. So we ended up doing 90% on that test, made one little small mistake there. Let's continue our learning here. Just check the time there. Perfect. All right. I believe that is all we're going to do at this point. I think we have a new static members kind of lesson next. So that will do it for this video. In the next one, we'll do our little introduction to static. If you did enjoy the video, please be sure to leave a like, subscribe, and comment down below any questions or comments that you do have. I've been Ethan. Thank you so much for watching, and have a wonderful rest of your day. Peace out.